Now we're going to do a section that I'm going to call Physics Bootcamp Test 3 Reviews Extras. I'm going to solve some extra problems that were not part of the review questions. Quite a bit of these will be in the regular notes that I cover for the bootcamp class. The first question will say, what temperature is there where the Fahrenheit and the Celsius are the same? So is there a certain temperature, a degree temperature, where the Fahrenheit and the Celsius reading are exactly the same? Okay. And is there a temperature where the Fahrenheit is twice the Celsius? And you could make a different combinations here. We could say Fahrenheit is 3 times Celsius, 1.5 Celsius, whatever you want. Well, you could, the way to solve this is you're going to go F equals 9/5 Celsius plus 32. This is the equation that governs the conversion between Fahrenheit and Celsius. So if you want the Fahrenheit and Celsius to be the same, you substitute F equals C, right? So if you put F is C, then you solve this equation basically. Well, you have here 5/5 C. You bring this over here, negative 4/5 C equals 32. C equals 32 times negative 5/4. And what does that give you? Well, 4 happens to go into 32 8 times, and that's going to give you negative 40 degrees Celsius. So actually, a Celsius temperature of negative 40 Celsius and a Fahrenheit temperature of negative 40 Fahrenheit, they are the same. A city which is negative 40 Celsius is also a city which is negative 40 Fahrenheit. The Fahrenheit and the Celsius cross each other at that point. How about a Fahrenheit that's twice the Celsius? Well, you put here 2C, 9/5 C plus 32. Then you bring this over. You have 10 minus 9 over 5C. You bring this over here, common denominator. You have 1/5 C equals 32. Right? And then C is equal to what? 160 degrees Celsius. So what will be the corresponding Fahrenheit? Okay? 160 degrees Celsius will equal 320 degree Fahrenheit. Because the Fahrenheit will be twice the Celsius, right? So at that point, the Fahrenheit reading is much higher than the Celsius reading. This is beyond the boiling point of water, right? How about if the Fahrenheit was 1.5 Celsius? Let's put it like this, 3/2 Celsius. Okay, that would be 1.5 of it, right? So then what's going to happen? Well, you're going to notice something here. When this number here, F, is less than 9/5 C, right? Then the Celsius is going to end up being negative. So here you put 3/2 C is equal to 9/5 C plus 32. Then you get a common denominator, 15 minus 18 over 10 C is equal to 32. Right? This one comes over here. 15 minus 18. That's negative 3/10 C equals 32. And then Celsius equals negative 320 over 3. And then what's the answer? Well, it's going to be negative 1. Okay, 3 goes into here 6 times, and 2/3 left over, so 6/7 Celsius, something like that. So does that temperature actually exist? Yes. You could have a negative 100 Celsius, right? And then what would be the corresponding Fahrenheit? 1.5 times that. Negative 106.66666 times 1.5. So you're going to have Fahrenheit is going to equal negative 160 degree Fahrenheit. Right? So that means the Fahrenheit this time is a lower reading. Right? It's a lower reading than the Celsius. So when they're 40, they're equal to each other. Lower than 40, colder than 40, the Fahrenheit is lower reading, so it's negative 160 than the Celsius. Greater than negative 40, the Fahrenheit reading is higher than the Celsius, right? Just like this, the Fahrenheit reading is higher. Well, How low can you go? Well, you can go to a degree of absolute zero, right? What is absolute zero? Celsius is negative 273.15, right? That's as low as you can go. What is going to be the corresponding Fahrenheit? So you put this into the equation for the Celsius. 9 times negative 273 divided by 5 plus 32. The corresponding Fahrenheit, negative 459.67 Fahrenheit. What's the ratio between the two? If you divide F divided by C, .68, right? So that means, you see, notice here, this is a ratio that is less than 9/5. 9/5 is a ratio of 1.8, right? So that's as low as you can go. You could go to a ratio of 1.68. Fahrenheit will be lower. And then how high can you go? Well, you can go as high as you want. The ratio of the Fahrenheit is going to be 10, 20, 30 times bigger temperature than the Celsius, okay? So this is kind of a good example to show the ratio of Fahrenheit to Celsius and then how to solve those kind of questions. Okay, thank you.